Today's video is going to be focusing on the last portion of our second success criteria, which is creating a mathematical model that relates the independent and dependent variables. Or in other words, we're going to be learning about different types of graphs. Traditionally, students are really excited about graphing because they immediately think they should make a bar graph. But bar graphs are only used to compare groups of data. So if you look at our example, we have a whole class of students and we categorize them into their favorite types of juices: red, orange, yellow, and purple. In chemistry, this is not one of the graphs we'll be using. The second type of graph students try to make is a pie chart. But a pie chart is only used to compare parts of a whole. Pie charts and bar graphs are related in that we're finding the different groupings, in this case, people's pie preferences. But still not a graph we're going to be using in chemistry all that often. But the graph that we will be using is something called an XY scatter plot. And this is to determine the relationship between two different variables. Well, in chemistry, that's going to be our independent and our dependent variable. There are many different parts of a graph that you have to remember. Most importantly, and this might seem really silly, is the title. If you don't have a title on your graph, your reader is not going to understand what is going on. Typically, and where we start off, is we have the name of our independent variable versus our dependent. And we'll learn throughout the semester of how to give more accurate titles. The second thing that we need in a graph in order to make it clear is we need to have a y-axis label and unit. So for example, this would be distance, that's my label, in meters, that's my unit. If we have a label and a unit on our y-axis, then we're going to need the same on our x. So another example, because our variables are going to be different, is time in seconds. So say we're comparing two different groups of data. We're going to have our trend line for one group of data, and then we're going to have a second trend line for our second group of data. So both of these are trend lines, and that kind of allows us to see which types of relationships are there. But because we have two different trend lines, we're also going to need a key. And the key is going to tell us what each trend line means. Remember, you only need this when there's multiple lines. However, when we use Google Sheets to graph, which we'll be learning about in class, Google will automatically put a key in there even if it's one trend line. That's okay. The last thing that you need in a graph is actually the most important. You must have a scale, and those represent the numbers used in your raw data. And the scale doesn't necessarily have to be the same on the x and y axis, but it has to start at 0, 0. You must have an origin. Because you can adjust the scale no matter what you need, the graph must take up the entirety of the axes you have available to you. So in other words, the graph must fit on the whole page. No one wants to see teeny little graphs because those are very difficult to read. Now, one of the more important things about graphing is determining the type of relationship used within the variables. So if you have a graph that looks like our first one, where it's going in an upwards motion from the bottom left to the upper right, this is called a direct linear relationship. And what this means is that if our independent variable increases, so what we are controlling increases, our dependent variable, what we're measuring, also increases. But because it's linear, it's increasing at a consistent rate. Note that I didn't say the word constant. In science, nothing ever increases or decreases at a constant rate. It will do so at a consistent, because generally our trend lines are a best fit and not connecting the dots. If you have a graph that looks like our second example, with a straight line going from the upper left to the bottom right, this is called an indirect linear relationship. In this example, our independent variable is still increasing because, to be fair, we are never going to have our independent variable decrease. It's a lot easier to add something rather than take it away. But in this particular example, if our independent variable increases, the dependent variable will be decreasing at a consistent rate. Our third example is dealing with exponential growth. And in this particular example, if our independent variable increases, then our dependent variable is also increasing, but at a changing rate. And in this case, faster rate. So in exponential growth, the dependent variable is increasing, but it's not consistent. In fact, one could use the word accelerating to describe what's happening in this particular graph. Our last example is exponential decay. And we're not going to see this a lot in chemistry, but it's important for you to understand the different types of relationships, especially for the ACTA test. In this case, our independent variable is still increasing because, again, easier to add independent variable rather than take some of it away. But if you see a graph like this, that means that our dependent variable is decreasing at a changing rate. And something to also consider is that in an exponential decay, the dependent variable will never be 0. And what that means is that this line right here will never ever touch the x-axis. That is in contrast to the exponential growth, because you may start with nothing, especially if you don't have any of your independent variable, but you quickly increase what you're measuring. These two graphs, direct linear and indirect linear, are two of the more common graphs we'll be using in chemistry to either support or negate our hypotheses based on our research questions. But as stated before, exponential growth and exponential decay are important to recognize, not only in chemistry, but also in your ACT exam. The next time I see you in class, we'll be learning how to use Google Sheets to graph, and your instructions are on the next page. Please take a look at those before class, and we'll go over how to actually complete these directions in person.